what we're going to do in this video is dig a little bit deeper into labor markets. And it's really not going to be any fundamentally new concepts. We're really just going to reapply concepts that we've already seen before and maybe use slightly different words. But the reason why labor is interesting is labor is one of the factors of production. It's one of the inputs you need for firms to produce whatever they do produce. And unlike in most markets, if we're talking about the computer markets, let me write over here. In the computer market, the demand is coming from individuals. So it's coming from, I'll just call it individual people, while the supply is coming from firms. In the labor market, it's the other way around. In the labor market, the demand is coming from firms. These are the people who need labor, who are hiring the labor. So this is coming from firms. And the supply is coming from individual people. So it's coming from individual people. And what's interesting about that is because the demand is coming from firms, in the past, when the supply was coming from firms, we could look at a firm's cost structure and we could come up with a supply curve from that. Now that the demand is coming from firms, we could look at a firm's essentially their revenue structure. How much incremental revenue do they get per extra employee? And we can actually generate a demand curve, their marginal benefit curve, by looking at their business a little bit closer. And that's essentially what we're going to be doing in this video. And these aren't any fundamentally new ideas. We're just applying them in a slightly different way, and we'll use slightly different words. Now let's assume, for the sake of this video, that I run a car wash. And it is a competitive car wash. I have to be a price taker. I do not have a monopoly or an oligopoly. I'm not even a monopolistic competitor. There are many car washes in the city. We are undifferentiated. We are all offering the same service. And so I'm going to be a price taker. And let's say the equilibrium price in this market for competitive car washes is $5 per car wash. $5 per car wash. And just as a little bit of review, that it also means, remember, this is a competitive firm, not a monopoly, that my marginal revenue is equal to a constant $5 per car wash. If I do one car wash, I'll get $5. Two car washes, $10. Three car washes, $15. In a monopoly, the marginal revenue would change. So let's think about how much benefit I would get from each incremental employee. So first, so let's make this column right over here. Let's take this L for labor. So this is going to be the quantity of labor. And I'm going to think when I hire 0 people, 1, 2, 3, 4, or 5 people. And then let's think about how much that we can produce when I hire these amounts of people. So I'll call that total product. Or we could call that total product of labor. It's essentially saying how many cars can I wash? And this is going to be car washes per hour. So cars washed per hour. How many cars can I wash per hour with the different number of people here? Well, if I have 0 people, I'm going to wash 0 cars. Let's say that I find if I have 1 person, that person can wash 5 cars per hour by him or herself. 2 people can wash 9 cars together. 3 people can do 12 cars. 4 people can do 14. And 5 people can do 15 cars together. And we can plot this. Let's actually plot this on a graph just to see what's going on. It always helps to visualize things. So that is going to be our total product. And this is going to be our quantity of labor. And the quantity of labor, we can have 1, 2, 3, 4, or 5 people. And this is actually 0 people right over here. And my total product goes all the way up to 15. So let's say that this is 15, this would be 10, and this would be 5. 5, 10, and 15. And so we can plot these points right over here. What is the total product? Well, this is 0, 0. 0 people, I'm not washing any cars per hour. Total product isn't cars washed per hour. If I have 1 person, I can wash 5 cars per hour. If I have 2 people, I can wash 9 cars per hour. 2 people, I can wash 9 cars per hour. 3 people, I can wash 12 cars per hour. 3 people, I can wash 12 cars. It's about right there. 4 people, I can wash 14 cars per hour. 4 people, 14's right about there. And then finally, I will do this in, well, let's see, I'm already using a lot of my colors. Blue's in pink. 5 people, I can wash 15 cars per hour. 5 people, I can wash 15 cars per hour. And so total product as a function of quantity of labor will look like a curve that looks something like this. I could just connect the dots, or I could make it look a little bit more curvy. So it's going to look something like that. And so one way that we should think about it, and as you'll see in economics, when you always want to think about how much you want to produce or how much you want to hire, you always want to think about how much benefit are you getting for that incremental thing. When you're thinking about your cost structure, how much cost for that incremental unit. When you're thinking about your benefits or your demand, you're thinking how much benefit am I getting from that incremental unit. So let's view this as the marginal. Let's write marginal product. MP. Sometimes in some economics textbooks I've seen this referred to as MPL, marginal product of labor. Actually, I'll just write the L there to make it clear. This is the marginal product of labor. So when we go from 0 people to 1 person, on average, between those 2 points over there, we're able to, our delta, our change, delta is just the Greek letter that symbolizes change. Our change in total product is 5. And so we can view that as the average marginal product, or you could kind of view that as the marginal product halfway between these, or you could view that as the average marginal product between those 2 points right over there. That's why I wrote it in a row that is in between these 2 points. It's taking us from 0 to 1. And actually, let me plot these while I draw them, while I calculate what they are. So I'll draw this one a little bit more flat, so I have space, which I can scroll down a little bit. So in this axis, I'm going to do marginal product of labor. And then on this axis, I'm going to have the quantity of labor. So this is 1, this is 2, this is 3, 4 people, and 5 people. So this point right over here, that's the marginal product of labor halfway. You could view this as the slope halfway between 0 and 1, or you could view this as the average slope from 0 to 1. So I'll plot it right over here. I'll view it, and actually I labeled these axes. So this is, let's call this 5, 4, 3, 2, 1. So halfway between 0 and 1, my marginal product of labor is 5, right over there. Then halfway between 1 and 2, my marginal product of labor, I go from 5 cars washed per hour to 9. So my marginal product of labor is 4. So between 1 and 2, my marginal product of labor is 4. And then between 2 and 3, my marginal product of labor, I go from 9 cars washed per hour to 12. So I have 3 incremental cars washed by adding that third person. So the average, you could view it as the slope right over there is going to be 3. So the slope right over there is going to be 3. I didn't make this completely to scale. And then these are a little bit more bunched up down here, but let's just keep going. Then going from 3 to 4, the marginal product of labor, I will go from 12 cars washed to 14. So I get 2 extra cars washed by adding that 4th person. So between 3 and 4, I get an incremental, on average, 2 cars for that extra person. And then finally, between 4 and 5, I get 1 extra car. So between 4 and 5, I get exactly 1 extra car. And so I'm going to get, and it looks a little bit like a curve here because I bunched up the measurements, but this really should be a line. This really should be a line. Maybe well, that's my best. I don't want to have to replot all the points, but this should be a line like that. Every time we moved up 1, we went down. We went down 1. Every time we moved up 1, we moved down 1. We see that over here. When we went to 5, 4, 3, 2, 1. So this is 5, 4, 3, 2, 1. So this really should be a straight line. So this is essentially plotting the slope of this curve at any point. Now, what we can think about is, because this by itself, this is telling us the marginal benefit in terms of cars washed, but this doesn't tell us the marginal benefit in terms of dollars. And to do that, we need the marginal product revenue, or you could call it the value of the marginal product of labor. And so let me write that over here. So we could call this the MPR for marginal product revenue, or we could view that as the value of the marginal product of labor. But essentially, we're just saying, okay, if we're washing 5 extra cars from that first person, and I'm going to get $5 per car wash, I have a constant marginal revenue. I am a price taker, then I'm going to make $25 on those incremental 5 cars. And if I wash 4 more cars, I'm going to 4 times 5, I'm going to make $20 extra. If I wash 3 extra cars, I'm going to make $15 extra. 2 extra cars, $10 extra. I'm just multiplying by 5 every time. This is times 5, times 5, times 5, times 5. If I wash 1 extra car, times $5 per car, I'm going to make $5 extra. And so essentially we could take every point on this curve and we could multiply it by 5 to get our marginal product of revenue, or marginal product revenue. Be careful where I say the ofs. So let me plot that, and I'll try to plot that a little bit neater so it's clear that this is a line. So that's my marginal product revenue. You could also view that as the marginal benefit calculated in terms of dollars. You could view this as the marginal benefit in terms of cars washed. This is the marginal benefit in terms of dollars. And right over here, we're going to have the quantity of labor. So 1, 2, 3. Actually, I want them to line up a little bit better. So 1 is right over there. 2 is right over there. 3 is there. 4 is there. 5 is there. 1, 2, 3, 4, 5. Let me scroll down a little bit. This is my quantity of labor. And the marginal product revenue goes up to 25. So let's say this is 5, 10, 15, 20, and 25. And so halfway between 0 and 1 person, so this is 25 right over here, I am producing $25, or I get an incremental revenue of $25 halfway on average. You can view this point right over here. Multiply it by 5. I'm getting to $25 on average for that incremental person. Then when we go to this point right over here, we're getting $20. We're getting $20. That's this right over there. Then when we go to this point in orange, if we multiply it times 5, we get $15. So this is 5, 10, 15. So that's halfway between 2 and 3. Our marginal product revenue is $15. So that is, let me make it clear, this is 15 right over there. And then halfway between 3 and 4 people, it's $10. Halfway between 3 and 4, it is $10. So it's going to look something like this. And then halfway between, finally, between 4 and 5, it is $5. It is $5. And so we're just picking points along here. We picked kind of the midpoint, the slope at those points, or the average slope between 0 and 1. But this is, if you assume this curve has a continuous slope, that the slope changes continuously, then this will be a line, and then this will be a line as well. So our line would look something like that. And what's neat about this line is essentially this is the marginal benefit curve for this firm as it gets more and more labor. So it's essentially the demand curve for this firm. And if you wanted to find the demand curve for the market, you could just take the demand curve for each of these competitive firms, and then you would just add them all together.